Hi everyone, welcome to Module 3, Part 2 of our Risk Assessment series. This is GCU from the University of Minnesota, and today we will be learning about the other mixture risk assessment tools for assessing emerging technology. In this part, our objective is to compare and evaluate other mixture risk assessment tools. Now that we've covered the fundamentals of control banding and occupational exposure banding, we will move on to look at additional tools. These include other control banding approaches and mixture risk assessment tools, which can help address situations where workers are exposed to multiple substances at the same time. Understanding these resources will give us a broader range of strategies for managing complex exposure scenarios. There are several specialized control banding and mixture risk assessment tools that can help address unique hazards. The CB Nano tool is designed specifically for assessing risks from nanomaterials, helping to guide control measures for these emerging hazards. Stupid Manager Nano uses a risk matrix to prioritize occupational health actions when working with nanomaterials based on both hazard and exposure information. The Structured Deterministic Model, or SEM 2.0, is a semi-quantitative tool used to assess mixtures. It identifies the controlling compounds in a mixture so that controls can be targeted effectively. The CB Nano tool works by using a decision-making algorithm that combines hazard and exposure information. It assigns a risk level, or RL, from 1 to 4, with higher levels requiring stronger control measures. The hazard assessment considers both the chemical toxicity and characteristics unique to nanoparticles, such as size, shape, and solubility. For exposure potential, it looks at how the material is handled, the level of ventilation available, and how long workers are exposed. This combined approach allows the tools to recommend controls that are tailored to the specific nanomaterial and workplace scenario. The CB Nano tool assesses several key factors to determine risk and recommended controls. First, it evaluates the physiochemical properties of the nanomaterial, such as size, shape, surface area, and solubility. It also considers potential health effects, drawing on any available toxicological data. Next, it examines exposure potential, including how often tasks are performed, the quantity of material used, and whether the process generates dust. Finally, it looks at the existing control measures already in place, such as ventilation systems, personal protective equipment, or contaminant method. The CB Nano tool is especially valuable for mixture risk assessment because it helps prioritize controls in situations where no occupational exposure limits exist. It also provides a structured framework that can be integrated into nanomaterial safety programs, ensuring that hazards are systematically addressed. In addition, the tool supports precautionary approaches, which are important in both research and industry settings where nanomaterial risks may not be fully understood. This makes it a practical choice for managing uncertainty while still protecting workers. While the CB Nano tool is a useful resource, it does have limitations. It relies on subjective expert judgment, especially when quantitative data is lacking. This means the accuracy of the results can depend heavily on the experience and perspective of the user. Additionally, the tool does not measure actual exposure data. Instead, it ranks risks qualitatively which means that follow-up exposure monitoring is still necessary to confirm that risks are adequately controlled. Here, it summarizes the key points about the CB Nano tool. In terms of how it works, the tool uses a decision-making algorithm based on hazard and exposure factors. And the tool assesses physiochemical properties, potential health effects, exposure potential, and any existing control measures. And especially, it's useful for mixture risk assessment because it helps prioritize controls when occupational exposure limits are not available, provides structured guidance for nanomaterial safety program, and supports precautionary approaches in both research and industry. However, as we discussed, it does have a limitation. It relies on expert judgment when the quantitative data is not available, and it does not measure actual exposure levels. Stofan Manager Nano works by combining hazard banding with exposure potential scoring. The hazard banding process groups materials based on their inherent health risks, while the exposure potential scoring evaluates how likely it is that workers will come into contact with the material. Together, these two components provide a structured way to prioritize controls for nanomaterial risks. Stefan Manager Nano assesses several key factors to determine risk and guide control recommendations. It looks at the physiochemical properties of the nanomaterial, such as size, shape, and solubility. It also considers the possible exposure routes, whether by inhalation, skin contact, or ingestion. Work environment factors are included as well, such as the use of contaminant, personal protective equipment, and ventilation systems. Finally, the tool uses these inputs to calculate an overall risk score, which is then used to provide ranked control recommendations. Software Manager Nano is a valuable tool for mixture risk assessment because of its user-friendly interface, which allows for quick and efficient risk evaluations. It also supports regulatory compliance and helps organizations strengthen their worker protection programs. Importantly, the tool assists industries in prioritizing resources for high-risk operations, ensuring that efforts are focused where they are most needed to reduce hazards. Stefan Manager Nano also has its limitations. It is not a substitute for exposure monitoring, meaning that actual measurements are still needed to confirm whether controls are working effectively. Additionally, the tool requires expert input to ensure that the risk rankings it produces are accurate. Without knowledgeable interpretation, the results could be misleading or incomplete. Here we have the summary of the Stofan Manager Nano tool. In terms of how it works, the tool combines hazard banding with exposure potential scoring to assess the risk. And it evaluates physiochemical properties such as size, shape, and solubility. And also it considers potential exposure routes like inhalation, dermal, and ingestion. And it reviews work environment factors, including contaminant, PPE, and ventilation. Stofan Manager Nano is particularly useful for mixture risk assessment because it has a user-friendly interface for quick evaluations, supports regulatory compliance and worker protection programs, and helps industries focus resources on the highest risk operations. However, it does have limitations. It is not a substitute for exposure monitoring, and it requires expert input to ensure accurate risk rankings. STM 2.0, it works by using structured checklists to evaluate exposures. Checklist 1 covers volatile and semi-volatile chemicals, while checklist 2 is for particulates, fibers, and aerosols. The tool applies deterministic modeling to calculate 95th percentile exposure estimates, which represent high-end but realistic exposure scenarios. These estimates are then compared to occupational exposure limits, OELs, to determine the appropriate exposure risk category. STM 2.0 assesses several factors to estimate exposure risk. It looks at chemical properties such as vapor pressure, molecular weight, and solubility. It also evaluates exposure determinants, including the duration of exposure, the control measures in place, and the chemical's volatility. When dealing with complex mixtures, the tool identifies the controlling compound, the one that drives the overall risk. Finally, STM 2.0 predicts exposure categories using tools like the Exposure Control Category, or ECC, and Health Effects Rating, or HER, to classify the potential risk and guide control strategies. STM 2.0 is well suited for mixture risk assessment because it's a step-by-step, user-friendly tool with clear guidance throughout the process. It provides point estimates for health risk prioritization, helping users determine which hazards require the most urgent attention. The tool is ideal for program management, regulatory planning, and even toxic tort evaluations. Additionally, STM 2.0 includes built-in calculators and reference databases, making it easier to perform accurate and consistent risk assessments. One limitation of STM 2.0 is that its accuracy depends entirely on the quality and completeness of the input data. If the data entered into the model is outdated, incomplete, or inaccurate, the resulting exposure estimates and risk categories may not reflect the true workplace conditions. This makes thorough and accurate data collection essential for reliable results. Here we have the summary of the key points about STM 2.0. In terms of how it works, the model uses two structured checklists to assess exposure. It then applies deterministic modeling to calculate 95th percentile exposure estimates and compares those estimates to its occupational exposure limits to determine risk categories. The assessment process includes looking at chemical properties like vapor pressure, molecular weight, and solubility. The model also predicts exposure categories using tools like the ECC and HER. STM 2.0 is especially useful for mixture risk assessment because it's a step-by-step user-friendly tool that provides point estimates for prioritizing health risks. However, the tool's accuracy is limited by the quality and completeness of the input data, making thorough data collection essential for reliable results. This table compares three mixture risk assessment tools, CB Nano Tool, Stofan Manager Nano, and STM 2.0, by their primary focus, key benefits, and limitations. The CB Nano tool is designed for health risk assessment of nanomaterials and is especially useful for prioritizing controls when no occupational exposure limits exist. However, it relies on subjective risk scoring. Stofan Manager Nano focuses on risk ranking and exposure prioritization. It supports regulatory compliance, but is not a substitute for exposure monitoring. STM 2.0 provides quantitative exposure estimates for chemicals in occupational settings, including 95th percentile ECC and HER, which support both prioritization and regulatory decisions. Its main limitation is that its accuracy depends on the quality and completeness of the input data.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.